Right, thank you. Still coming in. Okay, so we're going to uh, just revise, do some revision on the previous slide, which is yesterday, on the calculation of limit and feeds. As I did teach you that in this calculation, limits and feeds, we are referring to the British Standard 4500, okay, 4500s. And there are three types of feeds involved in this, which is known as a clearance feed. We have the transition feeds and as well the interference feed, iaitu padanan kelegaan, kita ada padanan peralihan, and as well we have this padanan gangguan. So every single of this padanan, okay, this feed type, I did explain about the definition, every single of the meaning, if you want to know about feeds. For example, I talks about what is the tolerance, okay, what is the upper limits, lower limits, and what is the deviation, what is upper deviation, lower deviation, and what you need to know about the whole basis system, what is the shaft basis system, and then about unilateral, bilateral. So all these things you need to understand, and if you not uh, if you can, then maybe you need to memorize it. Okay. So what did you see in front of you right now? It basically is to revise a few things before we go to the question, right? If you still remember, how can we know it is a clearance feed, transition feed, or interference feed? Is that by, you still remember this one? Still remember? Ali Huzaifa, Amar, you still remember this one? This is a clear, okay? Still remember, guys? Right? Ayuni, are you still remember? Yes, thank you, Arif. So still remember, this is the acceptable tolerance, okay, for holes, and on right my hand side is acceptable tolerance for shaft, the upper limits and the lower limits for shaft. And we have on this my left hand side is the upper limits of holes and lower limits of shaft. What I can say is that the maximum dimensions of hole, minimum dimension of holes, maximum size of shaft, minimum size of shaft. So in this situation is a, okay, like this, there will be a padanan kelegaan, okay, clearance feed, where you know the maximum size of shaft, this one, the maximum size of shaft is always smaller than the minimum size of hole. So it can go through like this. But if let's say it go this way, in this way, what you can see is that the minimum size of shaft is always bigger than the maximum size of holes. In this situation, it will be interference feed. If let's say the position of shaft, the maximum minimum size is this way, and this way, it will be a transition. Okay, so in front of you, you can see this is a clearance feed. Okay, guys, you can see that the whole dimension, the shaft dimension. Okay, we know that the size of the nominal size and the basic size is 30 mm, and we know that the maximum dimension of the diameter of hole is about 30.130, and the minimum is 30 0.000, and the maximum diameter size of shaft is 29.8900. Sorry, 29.890, and the minimum size of shaft is 29.760. So we can see from here is that the maximum size of shaft, the diameter of shaft is 29.890, which is always smaller than the minimum size of hole, which is a 30.000. So that's why this will be a clearance feed. So how you can calculate for clearance feed is easy. How to get the maximum clearance is by taking the value of the larger size of holes and you minus with the smaller shaft. Then you get a 0.370. That will be the maximum clearance, and the minimum clearance is the smaller size of holes minus with the larger size of shaft. Then you get 0.110. That will be the minimum clearance. If you look at this, my cursor in the, I try to sketch. I hope you can see my sketch, this one. To use red color. Okay, this will be the, okay. There is a, this will be the maximum. Can you see the sketch? Red color sketch. Okay, thank you. So this is the maximum values, how the maximum holes, this one, minus the minimum size of shaft. Then you get the maximum clearance. The minimum clearance, the minimum clearance is by taking this value, minimum size of shaft, minus by minimum size of hole, minus maximum size of shaft. Then you get this value. Okay, all right. Now, if you look at this transition, same. Okay, so again, please look at this size. You will see that what happened is that the size of the shaft is actually in between these. Okay, in between maximum size diameter of hole and minimum size diameter of hole. Okay, you can see the maximum minimum size of shaft is actually in between. It's like this, in between. So when it is in between, it's mean it's a transition, three condition. 1, 2, 3. Okay, so easily to calculate, you can get it by, how do you know the clearance? You take the largest size of hole, you minus the smaller size of shaft, then you get the clearance. Okay, so how to get the interference is by taking this smaller size of holes, this one, you minus the larger of shaft. That will be maximum interference, which is a minus 0.015. So based on the calculation, you will get that one will be positive, another one will be negative. So this is what we call it a transition. Okay, now interference feed. Again, please look at these two, the size of hole and the size of dimension. What you can see is that the minimum size of shaft is bigger than the maximum size of hole. If you still remember, when we talk about shaft, shaft is always will be in the internal side. Okay, now what we can see is that the minimum size of SHA is already bigger than size of maximum hole. It's an interference. It's like this. Okay, so interference. So how to calculate is that the maximum interference by taking the largest size of holes, okay, this one, and you minus the smallest. Okay, this one. Okay, that will be the minimum interference. The maximum interference is between this. Okay, the smaller size of the holes, you minus the largest of the shaft. You will get both value in negative. Right? Okay, now.
Sorry, doctor.
Yes?
I'd like to interrupt. I have a question regarding about the transition feed example.
Okay, wait.
Last
Okay, this one.
one
Transition. Okay.
Yeah,
This
this
one.
one.
Yes.
Why the clearance and the interference, right, is stated as max clearance and max interference in these cases? Why not one max and one min?
Oh, no. Because in the transition feeds, there is only two values. One is clearance, is one in interference. And the definition for this clearance and interference is the maximum. There is no minimum. Okay, we are not talking about minimum. Minimum is mean still under consideration, but in this case, there is a maximum. There is no minimum.
So
Okay?
we can say that the minimum clearance and minimum interference only exist in the clearance feed cases and the interference feed cases, right?
Yeah, the minimum clearance and the minimum interference only in the clearance feed and as well in the interference feed. There is no in the transition feed.
Okay, sure. Thank you, doctor.
Right. Thank you for the question. Okay. Okay, now. Okay, just to revise back. So how we want to, if maybe some of you missed this one. Okay, if let's say, against, we want to take diameter 10 mm. Okay, diameter 10 mm with, let's say, H7 P6. This one, H7 P6. Just to remind you, if someone asking, doctor, where this come from? 7 and 6. 7 numbers and 6 numbers is referring to what? Izian. Sorry, Izian ni nama selalu saya panggil sebab nama dia keluar kat depan saya. Izian, sorry for asking you. Izian, are you listening, Izian?
Yes, doctor.
Okay, Izian, bagi tahu kita H7 ni dengan P6 ni, P6. 7 dengan 6 ni apa? What is the meaning of 7 and 6? Mana datang 7 dan 6? Izian, where this come from, this number? Izian?
Shaft dengan hole, doktor.
Ha?
Shaft dengan hole.
Bukan. Saya tanya nombor tu. We have this H7. We have, boleh siapa ajar saya tak? Why when I'm sketch is disappear? Saya pun tak tahu what. Macam mana tak nak? Oh, disappearing. Then I have to use pen. Aduh, mak I lah. Senang aja kan? Saya selalu silap. Okay, lepas ni dia dah tak hilang. H7. And then P6. Azian, tengok sini Azian. Saya tanya. Ni, nombor ni. 7 dengan 6 ni, apa benda ni? Wah, best lah. My ink doesn't disappear anymore. Gambar saya nampak ke? Okay. Okay. Izian. Cepat
Tolerance.
saya nak bantu. Apa dia Izian?
Tolerance.
Tolerance. Saya nak kata salah pun tidak salah. Betul lah, it's a tolerance. Okay. Maybe kita cari orang lain pula. Saya nak jawapan yang lebih ni. Betty Robert, where are you Betty? Are you listening Betty? Betty, are you around? Are you listening? Betty, saya panggil banyak kali. Setiap kali dalam kelas saya ada panggil. Christopher, are you around? Okay. What did you know about that number, 7 and 6? What is that? Grades? Yes. Okay. I help you. It's a grade. Correct. Thank you, Christopher. Are you, Izian? 7 and 6 is referring to IT grades. International IT grades. Ingat tak? International Tolerance Grade. Yang ada nombor IT1 up to IT16. Still remember this one? Okay, saya tunjuk. Mungkin ramai yang tak perasan ni. Ni. Nampak tak ni? Okay, this one. IT1 to IT16. Okay. Right, jangan lupa. Teori benda-benda macam tu kena tahu. Okay, now. So, back to the question now. And then, Izian answering that just now about shaft and hole is correct. Okay, is referring to this. This is the big capital stand for holes, P small capital for shaft. Okay, so betul lah. Alright. Okay, now, so if let's say diameter 10 mm. Ali Huzaifah, are you around? Ali Huzaifah mana?
Yes, Doctor.
Okay, there are 210. One is here, the top one, another one at the below one. Which one we want to choose?
The top one.
Okay, why? What is the reason?
Sebab dia maksimum sampai 10 je kalau top.
Yeah, because referring to this. Thank you, Ali Huzaifah. Over 2. 2 is mean 10, this one. If let's say you say 10.10, that for example, then we refer it to the below one. It's mean over 10. Over 10 is mean it's not 10. It's the 10 point blah blah blah. Okay. So now Nur Alisa. Apa nama ni? Saya nama mana depan ni? Nur Alisa Shazliana. Are you listening?
Yes, Doctor.
Okay. Now, my question. Ali Uzaifa said that we're going to choose this one. Okay. Now, from this A7, P6, please give me the value for H7. Dia punya upper limit. What is the what is the upper limit? Sorry. What is the upper limit value? Nur Alisa. What is the upper limit value? Not Alisa.
Sorry, Doctor. I think
Huh?
15 ke, Doctor? I'm not sure.
You must sure it's a 15. Betul, jawapan kamu betul. Bagi saya value betul-betul. Multiply dengan ni. Remember, you must multiply this one. 0.001. So, what is the upper value? Dapat berapa? Alisa, cepat. 0. Alisa, tengok dekat table tu. Tak perlu calculate. You dah tahu dah jawapan dia berapa. Cepat.
0.15 ke, Doktor?
0. Macam mana nak padam ni? Oh, sini. Okay, 0.015. Okay, the below one, this one is the upper value, lower value 0.
000.
Okay, pandai. Thank you, Alisa. Okay, before Alisa, another question. Kalau tengok dekat sini, there is a 000 holes. This means this table is whole basis or shaft basis system. What is the answer, Elisa?
Whole basis, Doctor.
Why did you say it's a whole basis? Because of?
It's written there, whole basis.
Huh? Because it's already written.
Yes.
Okay. Yes, it's okay. It's true because it's already written whole basis. Okay. If you still remember the definition of whole basis system, go back to a few slides back. Then you will see that definition is telling us that, you know, when you use the whole basis system, the value of the nominal size and basic size, dia punya size tu, okay, is the exact size. Understand? So that's why you tengok dekat sini, if you look, guys, please, okay, if you look at all this value for holes, A7 ni, you will see that the minimum, the lower limit is all zero. All zero, this whole basis system. Understand? Thank you, Elisa. Okay, thank you very much. And now, iris. Wow, saya boleh iris. First time saya ajar dalam UTM ni pakai Google Meet, baru tahu benda ni. Sebelum ni saya pakai Webex. Webex memang saya tahu macam mana. Semua boleh. Saya tahulah sebab pakai Webex. Ni first time saya. Macam belajar pula. Okay, thank you. Right. So now we know how to read from the table, and we know how to use the table and how to get the numbers from the table, the values. And then another thing is that I did mention earlier the theory about this, where for the mating of this, okay, we have 27 deviation of shaft and as well hole. So dia ada 27 partner. So dekat sini you say A7 K6, A7 R6. So this is a standard that you cannot simply, like previously you said, how do we know the basics on nominal size when the numbers is 15 point blah blah blah, another one is 16 blah blah blah. Dia punya range tak boleh lah besar sangat. If let's say the numbers, the value is range difference 15 to 16 is impossible to be in when we talk about shaft and hole. It's impossible. Now we are talking for 3 decimal. Then it's impossible. Right? Okay. Now. Okay. Okay, this is the table, another table. I hope in front of you, you're going to have this table or other table. We're going to start, try to answer a few questions. Okay, guys. Oh, not this one. Not this one. Okay. I think we're going to have a question. We try to answer question from this one. Okay. Can you see this PDF file? Oops. Why this one? Oh. Okay. All right. Okay. We're going to have a practice for this. Okay. I give you 5 minutes. 5 minutes. We're going to stop at 9:10. Please answer question number 1. All of you, I need the answer. 5 minutes. Start from now.
Sorry, doctor. I would
Yes.
like to ask, do you have an English version of this one?
I don't have the English version of this slide.
Uh,
Okay, I'm going to assist you. Okay, no, don't worry. I'm going to assist you. This question, why it turned into 2 pixels? Okay, the first one, he said that it used a whole basis system, and the size given is been stated where they give it the fits for shaft and holes. The first one is the diameter for shaft. Second one is a diameter for holes. So it already give you the maximum size of diameter of holes. This one,
okay.
okay. Minimum diameter size of shaft. Sorry, shaft. Maximum size of shaft. Minimum size diameter of shaft. Maximum diameter size of hole. Minimum diameter of holes. And question asks you, the first one is, what is the basic size for this fit? Second question, what is the tolerance for shaft and holes? Third one, question asks, is it clearance fit or interference fit? Is it okay?
Okay, doctor.
All right. So please answer it. I give you 5 minutes. We're going to stop. I'm going to ask you at 9:30. 9:30. 9:13. Right, guys? Right. So what is the... Sorry.
$45.00. 45.00.
Okay, thank you. Oops, tak boleh start. Okay, the first answer is 45 mm diameter. Thank you. Siapa tadi? Anif, Muhammad Anif Hakim, thank you very much. So the answer is a 45 mm. I did teach you yesterday. Did not mention any value after point, whatever it is. For example, 0.025, 0.002. Okay, the norm size, the basic size is before the point, the number before point. So it's a 45 mm. Thank you. Okay, for the second one, anyone volunteer? Anyone?
0.016.
Okay, wait. Oops. Okay. Okay. What is the tolerance for shaft? 0. Hanif,
0.016.
6 mm. Jangan
Ah,
lupa letak mm. Okay. Okay, what is the tolerance for hole?
0.025 mm.
Okay, I need someone else. Muhammad, Hanif, Hakim dah jawab banyak ni. Lau Zeng, are you around, Lau Zeng?
Yes, doctor.
Okay, if possible, can you answer the question C? But I need, is it clearance or is it transition or is it interference?
It's transition feed.
Transition feed. Okay, now, what is the maximum clearance value?
0.023 millimeter.
0.0.
23 millimeter. Positive 0.023.
Okay, let me check. 25. Okay, all right. Where we take the maximum, the maximum values, positive and minus 45.0025, 0.02.
Maximum
Okay.
hole size minus maximum shaft size.
Yes. Okay. And okay, I need some. Thank you, Lau Zeng. Anik Hazlan. Anik Hazlan. Anik Hazian. Anik Hazian.
Yes, doctor.
Okay, what is the answer for maximum interference for this transition feed?
Negative 0.018.
0.018.
018.
Is it correct, guys? Okay, thank you. So this is the answer. I think this group very good. Dapat jawab dengan baik. Alright. So keep this answer and try to understand. Okay, now we go to the next question. Okay. Oh, dia tak hilang. Boleh kecilkan Dia tak boleh kecilkan. Tak boleh kecil. Oh, it's okay. Okay. Now please look at this second question. Macam mana saya nak buang ni? Tak boleh buang pula dah. Kena pilih. Udah.
Doctor,
Ah,
I have a question about the calculation of minimum and maximum clearance one. The C,
yes.
why is it always the hole diameter minus shaft diameter, or it's actually depends on the basic system? Either it's hole basics, then we use hole minus shaft, or it's shaft basics, then we use shaft minus hole. Or is it always we use the hole size and then minus the shaft size to determine the clearance and interference?
That's why in this, okay, like this. I always teach my student. Some of them say there's a formula. For me, you have to look into the situation. When we say maximum, it must be maximum. So that's why in the earlier, you have to know what is the heart trimmer, okay, what is the upper limits and lower limits, and you have to sketch. By looking at the sketch, then you will select which one you need to minus with. Okay, it's based on the condition. If let's say like this, and like this, there will be different condition. The only thing is that you need to sketch first. Okay, you need to sketch first, and then you will know which one.
Oh, okay.
Okay, all right. Okay, thank you. So now, please go to the next question, question B. But please, someone help me. How can I delete this one? It cannot be removed. Is it? Oh, erase. Is it erase? Erase all.
Yeah, I think eraser.
Eraser. Or if let's say clear all, no. If let's say eraser, okay. Okay, now. Second question. Okay, there is a butch. Which size hole is diameter 35 mm, H7, IT7, and which is shaft size of diameter 35 K6 were being used in 1 feet. So please get the values if the whole basis system being used. BS 4500. First question, please get the limits for both of them. Limits. And what is the second one? What is the tolerance? Third one, is it clearance feet or is it interference feet? So please calculate. You need to have the table H7K6. Okay, please refer to the table H7K6. Wait. Oops, not this one. The previous, you have to check to the notes. Okay, the previous one. Wait. I check with you. Is it possible to get this one? Can you see from in the slide? Please check, refer to this. Oops. H7. Okay, this one. You can use this one. H7K6. Okay. This is the this the whole basis system. So question is ask you to use the whole basis system. So you can use this table. Okay. You can use this table. Okay, you can use this table. H7, K6. Okay, I'm going to help you first. It's a diameter 35, correct? Okay, the question asks us to use the diameter 35, use a whole basis system. referring to BS 4500. So which one? 35. Anyone? Ian Zisco. Ian, are you listening?
Yes.
Okay, now we have this. The question asks diameter 35 mm. So now we have here this one, correct? So we going to get this value. Okay, is 7K6. This one. Okay, now guys, please answer the question. 5 minutes. 9:28. I'm going to ask you. Go back to the question. Wait. Okay, can you see the question? Okay, please try to get the answer. 5 minutes. Right, guys? Okay. Lau Jiahi, are you listening?
Yes, doctor.
Okay, can you give us the answer for A? The limits for both component. What is the limit? The limit is mean upper. Okay, you give us the upper and lower limit for the whole. What is the upper limit of whole?
Wait. I think it's like 30, right? If I'm not mistaken.
Huh? What is that? What is the upper limits and lower limits for whole when you refer to the table just now? Do you have the answer or not? $35.025, $35,000, 025. Oh. Okay. Someone already answered 35.025 and 35.00 is correct. MM. Okay, thank you. And what is the answer for upper limit and lower limit for the shaft? Please give me the answer. Anyone?
35.018 and lower limit is 35.002.
35.018
18.
and
35.002 for lower limit.
35.002. Okay, double check, guys. Is it correct? Please. Okay, thank you. All right, we have the answers. Okay, for the next question, B.
It's like a thing.
Oops, how to delete? What is the tolerance for hole? The tolerance value of hole?
0.025.
25 mm. Sorry.
0.025 millimeter.
For the tolerance for hole. What is the tolerance for shaft?
0.016 millimeter.
Okay, thank you. Is it correct? Double check.
Yes.
Okay. Thank you. Okay, now C. Is it clearance or interference or transition?
Transition feed.
Transition feed. Is it correct? Double check.
Yes.
Please give a thumb. Okay, all right. So what is the value for the maximum clearance?
Positive 0.023 millimeter.
23 mm. And what is the minimum maximum interference value?
0.018 millimeter.
0.18 millimeter. Is it correct? Okay, thank you. All right, done. Okay, hopes everyone clear about this. And we're going to, we have to look, wait. Okay. Not to answer question number 3. I think you can answer all these questions. I think you will see, doctor, why the question is all the same? Yes, it's macam tu jugalah. Soalan dia just pusing situ. Okay. But I want to show you other type of question mungkin satu. I'm not going to discuss about your test will be in this Thursday, correct?
Doctor, they just sent a new version
Yes.
of timetable. It changed
Yeah.
to Saturday.
Yes,
already.
yes. Yeah. I just want to, I did not receive yet, but I think it's already come out until this evening just now. I did not receive. They said do not discuss with student, but I just want to let you know the date will be changed. Okay, it will be is it in the Saturday? Yes, Saturday. So our test will be postponed to Saturday, guys. So you have a time. Okay, please, I'm going to give you a few questions to be answered and send it to the e-learning. I want to see all my students to get higher marks. I don't want to listen that, doctor, I just got a few marks. No. I try my best to teach you for these two second chapter, and I did assist you to give you some tips how to can you score. Later on, we're going to have tutorials. Some of you asking, is it possible for me to, to share with you how to answer the question, not to say schema, but is how the way to answer it correct way. If not, then you will going to lose a mark. Okay, I'm going to have that session later, not today. Okay, all right. I think I want to show you one question. I think it's enough. Not too many of them. Soalan kebat lah. Saya kata soalan kebat. Okay, let me see this one. Okay. Okay, can you see it in front of you now? Is test 1. Okay. It's a test 1, semester 1, session 24-25. We're going to answer a question for a latest one later on. Okay. Okay, now. Question 7. Okay, we try to answer question 7 first. Okay, question 7. I want you to give the answer. Okay, this is using the sharp basis system, H6 and N7. Okay, I give you straight away the values. This is the wrong way of writing. This is an error. It should be N7 first and H6. So please check from this. N7. Oh, this is wrong. It's supposed to be...
Doctor,
okay.
the question mentioned shaft basics, right?
Pardon?
The question mentioned shaft basics, right? If the alphabet, the capital alphabet is in front, is whole basics, right? This one.
Yes. This is the sharp basis system. Yes, correct. Okay. That's why I want to check. Okay. Okay, now is a H6 and 7. Okay, this one. And 7. Just let me check first. Okay, correct. Okay. It's true. It's a sharp basis system. Okay. H6. Why they give it like this? Okay, what is the value for A6 50 mm? Sharp basis system, it should be 0. Same go with this one. Yeah, why they give 2? It's similar. It's a 50 mm. So we choose the top one. So you will use A6. Okay. Please write before we, because you don't have this table. Okay, this one. Okay, 50 mm. A6. This one. This is a lower 0. Oh, sorry. Okay, this one. 0 and 16. Okay, 0 and 16. And then this one is A6. Tak berapa ingat lah. Okay, 1 and 7. No, this one. Okay, this one. And 7. Padam sekejap. Nanti kan salah. And 7 is 50. This one. This 50. Oh, sorry. This one 50. And 7 is here. So the value is 8 and 33. So, okay, tolong ingatkan saya. Apa ni value ni? Kang saya nak tulis. What is the value for... Susah lah pakai ni. Tak tulis. Susah. Not to write, I want to type. Okay. What is the norm size? The norm size is, anyone?
50.
Okay, 50 mm. And what is the what is the upper limits of shaft? What is the maximum upper limit of shaft? 50?
50 also.
50 upper limit of shaft, yes. Why? Why
Lowest,
is 50? Why?
because the upper deviation is 0.
Yes, why?
Because this is a shaft basic system.
Yes. Thank you. Good answer. Correct answer. Perfect. Because this is a shaft basic system. So when basic shaft basic system, the norm size and basic size is similar to the exact size. So it's a 50 mm. This will be the upper limit of shaft. And what is the lower limits value?
49.086. 49.084.
084.
Ah,
Oh, sorry. 49.084. Double check. Is it correct, guys?
yes. Yes.
Tak ada orang double check ke?
Yes.
Senyap aja tu. Anyone, please give thumb. Double check. Tak ada? Mesti double check. Okay, thank you. Okay, now, what is the upper limits of hole?
Uh, 49 49.992.
49.992 mm. And what is the lower limit?
49.967.
967. Okay, double check. Is it correct? Seorang aja menjawab.
0.033.
Mana yang lain ni? Double check. Is it true? The question should be ask limits first and then ask the tolerance. Now the question ask tolerance first and then ask the limits. Okay, thank you, Arif. Okay, next. What is the tolerance for hole, for shaft? 50 minus 49.084. 0.0.
0.016.
Huh?
0.016 millimeter.
0.016 mm. And what is the tolerance for hole?
0.025 millimeter.
Okay, double check. Is it correct? Sometimes, guys, it was a very simple calculation, but lots of students make mistake. If in the earlier you make a mistake, then the rest will be wrong. So be careful. Okay, now, is it minimum and maximum tolerance? Tak payah jawab lah yang ni. Okay, now, last question for tonight. Last question for tonight. Okay. Please answer question number 6. Please answer question number 6, guys. Okay, number 6. Please answer question number 6. This one. Please answer. I give you 5 minutes. This will be the last question today. Okay. 9:50.
Doctor, I have some
Yes.
question regarding about the question 7 you just showed. Now, what's the differences between the B and D? The tolerance of the shaft and hole and the minimum or maximum of tolerances.
Okay. If you look at this, the question, okay, this question, if they ask you, for example, norm size, tolerance for the shaft and holes, and then I don't know why they said minimum and maximum. Maybe because sometime, okay, sometime in the question they do the question asking in the wrong way. Okay, I don't know why they put minimum and maximum of the tolerance. We will see. Maybe for this question, normally it's been asked what is the
Clearance.
minimum and maximum of clearance. That will be okay. Okay, what is the minimum maximum clearance? What is the minimum maximum of interference? That is fine. Maybe it's been corrected in the exam. Maybe.
Oh, okay. Thank you, doctor.
Okay. All right. Thank you. Okay, guys. Last question. 4 minutes more. Question number 6. Okay, an assembly consists of 40 mm shaft, where this shaft is rotates in the bearing housing, and the tolerance for both shaft and bearings is 0.05 mm. And by using a relevant sketch, determine the level, the limits, upper limit, lower limits of the both shaft and bearings to give a maximum clearance of 0.07 mm. Okay, by considering that you use the whole basis system. In this question, I give you some tips. The tip is that this one, 1, 2, 3. Okay. Play around with the equation, the calculation that you have previously. Okay, they give you the tolerance is the same, 0.05 mm, both of them. Okay, both shaft and bearings. Okay, holes and shaft, same. 0.05 clearance gap is the same. Oh, sorry. The shaft and bearing is 0.05. And they give you the upper limits and lower limits of both shaft and bearings to give a maximum clearance is about 0.07 mm by considering by use a whole basis system. Whole basis system. The basic size, the norm size for the shaft is equal to the exact size. Alright, guys. Anyone? What is the upper limits and lower limits for both shaft and bearings? That is the only answer that we need. What is the upper limit for shaft? And what is the upper limit and lower limit for holes? Anyone? As they did mention that this assembly is going to Arif. Okay, thank you. For holes is 40.050 mm. This is for hole. Okay, and the lower limits is 40.00 mm because it mentioned in the question that we use the whole basis system. Okay, then the clearance, okay, the tolerance is 0.050, so you just plus 40.000 plus 0.050, so you get the upper limits for holes is 40.050. Okay, now what is the tadi ada jawapan ya? Okay, another answer. What is the size of what is the answer for the shaft? The maximum, the upper limit is 40.030 mm and the lower limit is 39.980 mm. Okay, double check. Anyone say correct? Please give a thumb for this answer from Muhammad Arif Hakimi. All right. Thank you very much, Muhammad Arif Hakimi. So please keep this answer for those who are still, you know, how can he get this? Okay, keep this answer and try to find out. Okay, try to find out. So normally in test 1, the question is like these two type. One is a straight way, another one is quite tricky. Not difficult, but you need to know where is the point that in the answer that lets you to start calculate. You can get the answer easily. Okay. So I think that will be our session revision for the calculation tonight. If tomorrow, I think we have a class in the morning until the afternoon. Maybe we will go to the next chapter and we try to find any suitable time, maybe at night or evening, that we try to have some short discussion, not like this. This is stuff maybe about 1 hour, less about 50 minutes. Okay. All right. Thank you guys for joining this session tonight. I will see you again next morning. Okay. Thank you very much and have a nice dinner. Have a nice rest tonight. Thank you very much and Assalamualaikum. Thank you guys.
Thank you, Doctor.
Thank
Okay.
you, doctor.
Thank you, Doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Okay. Sama. Ya. Besok kelas online lagi. Just to inform that hari ni saya banyak berubah. Penat tu dah makin tak ada. Yang peliknya saya tak makan ubat. Saya tak tahu adakah sebab ubat tu menyebabkan saya jadi macam tu, saya tak pasti. Saya nampak okey, tapi saya still running online. I'm not going to stand. Yelah, dalam masa kita nak tunggulah, it will take some time. Doktor kata it will take some time. Okay, we still run online. Okay, alright. See you tomorrow online. Okay, sama.